The Black Death. Just the name itself sends a shiver down your spine, doesn't it? It conjures images of the medieval period, a time of immense fear and devastation as the plague tore through Europe, leaving millions dead in its wake. The culprit was a tiny bacterium, Yersinia pestis, hitching a ride on fleas that jumped from rodents to humans. It was a terrifyingly efficient system of transmission. But what if I told you that long before this infamous pandemic, another plague, a more ancient and mysterious one, was already making its way across Eurasia? This wasn't the Black Death we know from history books. This was a much earlier version of the plague, one that emerged around 5,000 years ago during the Bronze Age. For 2,000 years, this ancient lineage circulated, a silent threat moving across continents, before it vanished from the historical record. The mystery of this Bronze Age plague has puzzled scientists for years. How did it spread so far and wide? The key difference is in its DNA. This ancient strain lacked the specific genetic mutations that made the medieval plague so effective at being transmitted by fleas. Without that flea-based superhighway, how did it travel from person to person, community to community, across a vast landmass? It's a question that has remained unanswered, a gaping hole in our understanding of one of history's most notorious diseases. But now, a groundbreaking discovery might finally give us the answer we've been looking for. And it all comes down to a very, very old sheep. An international team of researchers has uncovered something extraordinary in the remains of a 4,000-year-old domesticated sheep. These remains were found at Archaeum, a fortified Bronze Age settlement in what is now Russia. Archaeum is often called the Russian Stonehenge for its complex, circular structure and is considered a major hub of its time. And within the bones of this single animal, they found the smoking gun, the DNA of Yersinia pestis. This is the first time we've ever found direct evidence of the plague in a livestock animal from this period, and it completely changes the game. Think about it. The Bronze Age was a time of huge societal change. People were settling down, building cities, and crucially, domesticating animals on a massive scale. Sheep, goats, and cattle weren't just a source of food and materials. They were a part of daily life, living in close proximity to humans. So let's connect the dots. We have a plague that can't be spread effectively by fleas. We have societies that are increasingly dependent on large herds of livestock. And now we have direct evidence of that very plague in a sheep. The new theory is that this ancient plague didn't need fleas to travel. It may have spread through direct contact with infected animals. Imagine a herder tending to a sick sheep, or a family consuming contaminated meat or milk. The bacterium could have passed from animal to human through simple, everyday interactions. This also explains how the plague could travel such vast distances. The Bronze Age wasn't static. It was a period of extensive trade and migration. People moved, and they took their livestock with them. A herd of infected sheep, traded or driven hundreds of miles to a new settlement, could have carried the plague along for the ride, introducing it to new, unsuspecting populations. Livestock, the very foundation of Bronze Age society, may have also been its Trojan horse, carrying a deadly pathogen hidden within. The implications are huge. This finding forces us to rethink the entire history of pandemics. It suggests that zoonotic diseases that jump from animals to humans have a much deeper and more complex history than we previously thought. The rise of agriculture and animal domestication, which we see as a cornerstone of civilization, may have also opened a Pandora's box of new diseases. What's really fascinating is that this Bronze Age plague lineage eventually died out. Why? Well, that's the next big question. It's possible that as human societies evolved, our relationship with livestock changed. Maybe we developed better hygiene practices, or perhaps the bacterium itself just wasn't as well adapted for long-term survival in human hosts compared to its later, flea-borne descendant. Another theory points to the plague itself. The later Black Death strain of Yersinia pestis was so successful because it could survive in fleas, creating a persistent reservoir in rodent populations. The Bronze Age strain, lacking this ability, might have been more prone to burning itself out. Once it ran out of susceptible hosts in a given area, whether animal or human, it might have simply disappeared. The discovery at Archaeum is like finding a long-lost chapter in the story of human disease. It shows us that to understand the pandemics of today, we have to look deep into our past, to the very moments when our relationship with the natural world began to change. That 4,000-year-old sheep isn't just a pile of ancient bones. It's a witness to a forgotten plague, a key that unlocks a new understanding of how diseases have shaped human history from the very dawn of civilization. This research reminds us that the threats we face from infectious diseases are not new. They are an ancient and ongoing part of the human story. By studying these ancient pathogens, we can learn valuable lessons about how diseases emerge, how they spread, and how they can be controlled. It's a powerful reminder that our past is always present, and sometimes the biggest secrets are buried right beneath our feet. Thanks for watching. If you found this journey into our ancient past as fascinating as I did, don't forget to like this video and subscribe for more stories that connect science, history, and the world around us. See you next time.